So in today's video, we are diving deep into Git and GitHub. Whether you are a beginner or experienced developer, understanding on version control system, what are the various Git commands and their purpose, and how to collaborate with others' work. So all this is super essential. So this video will cover everything you need to know about Git and GitHub. So in this video, we will be covering basics of version control system, Git setup. So basically we will be talking about the installation process of Git setup. So how to manage repositories online. So we will be talking about the GitHub. So finally, we will be covering all essential Git commands that we need to know. Okay, so next question is, what are the version control systems? So version control systems are the software tools that help software team to manage changes to the source code over time. Or you can say it's like a timeline to our project that allows us to save checkpoints and easily roll back changes if something goes wrong. So Git is one of the version control systems to track the changes in source code. Okay, the question is why version control systems are important, right? So let's try to understand from this real world example. Imagine I am writing a book. So for example, so I have written something that is my chapter 1, right? So this is chapter 1. And then I started writing chapter 2 in this book. So this is chapter 2, right? Similarly, I have chapter 3. Now after writing all that, I think chapter 2 needs a bit of tweaking, right? So for example, so I made some changes here in chapter 2. I made some changes. So by deleting the previous content and writing the new content. But later I realized these changes are not as good as I was thinking. So I want to roll back to the original version of chapter 2. So think, if I do these changes manually, because I'm not using a version control system, so there are high chances I don't get exactly the same version which I required, right? So this is the first problem if we are not using version control system. Let's consider the second scenario. It's not just me writing the book. Let's say there are 3 or 4 people working with me, right? So for example, I am working on chapter 1, right? Someone else who is working on chapter 2. Similarly, some other person who is working on chapter 3, right? So at some point, I decide to make some changes in chapter 2 while the other person is still working on it. So for example, at some point, I started writing something in chapter 2. So there are chances maybe I rewrite part of their work without even knowing they are in the middle of something important, right? So now we got a big mess with 2 different versions of chapter 2. So and we don't even know which one is the right one. So now we have 2 challenges. So first one is track changes and second one is collaboration with others. And to resolve these 2 issues, version control system is super essential. So now think the same situation in terms of software development where we need to track the changes in source code and need to manage the collaboration of work, right? So we definitely need a version control system. So Git is one of the most popular version control system which we are going to learn in this video. So Git is one of the version control systems which helps to track the changes in source code and also manage the source code collaborations. So in this video, we are going to cover everything which we require to know about Git and GitHub. Now let's talk about GitHub. So GitHub is an online platform for storing projects. So GitHub is like an online storage space where we can keep all our coding projects called repositories. So basically, whenever we are talking about projects, so in terms of GitHub, so we will be calling these repositories. So instead of saving our code just on our computer, GitHub allows us to store it safely on the cloud so we can access it from anywhere. So basically, so for example, this is the GitHub. So where we can store our projects, and these projects are called repositories. So easily manage code using Git. So basically GitHub works with Git. It helps us to keep track of every change we make to the project, just like a time machine to our code. So we can see who made what changes, revert to the previous versions, and it makes sure nothing important gets lost along the way. So next point is share code with others, right? One of the best things about GitHub is that we can share our work with others with just a link. So we will be looking into that practically after some time. And the last thing about GitHub is collaborate and contribute easily. So GitHub is not just for storing code, it's also great for teamwork. Other people can look at our code, they can suggest improvements, and even they can contribute their own code, right? So let's see how to create GitHub account. So for that, we need to navigate github.com. So we are on github.com. Let's click on sign up button at top right corner. Email address, let's go together. Continue. Add some password. Continue. Let's code together. Let's go together. User 1. Continue. Submit. So after this verification, we will be getting some code on the registered email. So we will be navigating to this page. So enter username or email address here. So let's go together hyphen user 1. So we can enter username or email. Enter password here. So first time it will be asking some questions. How would you describe yourself? How many team members will be working with you? Just me. So you can select options here. So start a new project or contribute to open source projects. So here on this screen, select continue for free. So this is the dashboard. There are so many options we can see here. So click on your repositories. So here we are on our repositories page. Let's create our first repository here. So we can create first repository by clicking on this new button. So on this form, first we need to give some repository name. So I am calling it first repo. We need to provide some description. This is optional, but let's give some details. Let's make it public. And finally, create repository. So this is the first repo, which is the public repository. And as of now, there is no file in this repository, right? So let's add our first file in this repository. So for that, we have options here. Either we can select creating a new file here itself, or we can upload an existing file, right? So let me add one file using create a new file. So for example, my first file is 1.txt, right? So just for understanding, I'm just creating the text file, and we can write some text here and commit changes, right? So whenever we are committing the changes to the GitHub, we need a commit message here. Initial commit 1.txt edit. Commit changes. You can see 1.txt file is there, and commit messages initial commit 1.txt, right? Now let me do some changes in this file. So this was the original content. So let me add something here. Edit this file. This is updated text, right? And I am committing the changes again. So here, updated text in 1.txt. So you can write any message here. And when I'm committing these changes, and let's go back to the first repo. So updated text in 1.txt, right? So this is the commit message. And here you can see two commits. So if I click on this, so you can see the history of commits here. So initial commit 1.txt, updated text in 1.txt, right? So whatever the commit messages we have given in all our commits, so you can see here along with their time, and every commit has some code. So you can see here. So here, let me do some more operations. So if I go back here on code, so let me add one more file here. So add file, create new file. For example, this is another file, another.txt. This is another file, right? And commit the changes. New file, another.txt, edit and commit changes. So now in this repository, we have two files, one.txt and another.txt. And you can see the commit messages. For another.txt, we have new file, another.txt added, right? So let me do one thing again. So in one.txt, let me update the code again. So edit, this file is updated second time here. So whatever the changes we are making, so we are committing, and every time when we are making a commit, so we need to give some message, file updated second time, right? Commit changes and going back to this repo. Along with any file, you can see the latest message or latest commit message. So one.txt file updated second time, right? And now we have 4 commits here. So you can see all commit history is available here. So let's do one thing here now. Let me delete another.txt file. So I am deleting this file. Even for deleting, we need to commit the changes here. File deleted and commit changes, right? So now we have one.txt only, but if I click on this history, so you can see commit history is available here. So till this point, we have good understanding on how to create our GitHub account, how we can create repository, and how we can perform various operations on repository like adding new files, deleting existing file, or updating existing file, right? So all this we have done till this point. So as we discussed in our first slide, so GitHub is online cloud where we keep our repositories, where we keep our projects, right? And Git is a version control system, which is a software that we need to install on our local machine. And by using Git software or Git tool, we can manage our local repositories on online platform, that is GitHub, right? So let's see how to install Git. So on this Google page, we need to search install Git. And you can see this second link, which is git-scm.com downloads, right? So let's click on this downloads link. In this downloads section, you can see the Git is available for various operating systems. So first, let's see how to install it on Mac. So Mac operating system, click here. To install this on Mac operating system, there are multiple methods to install that. So you can install using Xcode, using Mac ports, binary installer, right? So there are multiple ways. So one of them is using Homebrew to install Git. So click on this link. So to install Homebrew, use this script on your terminal and Homebrew will be installed, right? So once Homebrew is installed, then you just need to execute this command, brew install git. So this will be installing the Git on your system. So once Git is installed, just open the terminal. You can run git version. So I have already installed Git on my computer, but you can verify your installation status by using git --version command, right? And to install Git on Windows, so you can see there are various options which we can use. So for example, this is 64-bit Git for Windows setup, right? So click on this and you can see the installer is being downloaded, right? So once this is downloaded, so you can just install the way you are installing the other softwares. So this is the Windows installer. So just like Mac operating system, so you can use git version command on Windows command line interface as well. So you can see if the Git is installed or not. So you can verify by using this command, right? So we have installed Git on our local system. So let's configure Git with our name and email address. For that, we have git config command. where we need to specify the username and user email address, right? So we have Git installed on our system. So let's configure username and email. Git config global user.name. Let's code together hyphen user1, right? And similarly, git config global user.email, that is, let's code together 01012001 at the rate gmail.com, right? So we have configured username and email here. And if you want to verify if these settings are already done, so what we can use, git config hyphen list. So you can see username and given email is configured with Git, right? So before proceeding with other Git functionalities, so I just want to explain a few CMD commands that we are going to use in this video. So first, clear, or on Windows we use CLS, so which is not available here, but on Windows you can use CLS. So here we have this clear command to clear the screen. So this is my home directory where we are. So if I want to see what all files or folders are available in this folder or in this directory, so we have ls command. So currently we are in the Pravinder directory, right? Which is my home directory and which contains these files and folders. If I want to change the directory, for example, from Pravinder, I want to navigate to desktop directory. So what we can use, so cd for change directory, desktop, right? And enter. So you can see currently we are on desktop directory, right? Similarly, if I want to see what all files and folders are available in desktop directory, so ls. In this directory, if I want to make further any directory, so for making a folder or directory, we have mkdir and name. For example, name is test. So test is created, ls. So you can see we have two folders, my folder and test folder, right? And if I want to navigate into test folder, so change directory, test. So now we are in test directory. And if we want to come back from some directory, so we have cd space two dots. So if I do this, so you can see initially we were in the test folder. Now we are on the desktop, right? And if I do that again, cd dot dot. So now we are in the home directory. So with cd, we can change the directory if we are applying the name here. And if we are passing cd dot dot, then we are coming one step back. So in this Git configurations, so we have used global, right? Global user.name, global user email. So basically this global is the level. So at what level we want to save these changes or we want to configure these changes. So basically we have three levels: system, global and local. So in this settings, so we have used global, right? So in place of global, so we could use system or local as well. So system level configurations means, so those configurations would be available for all users for the current system or for that computer. And if we are making the global configurations, so all repositories for current user are accessible. For example, we are working on multiple repositories, right? So we have multiple projects and the current user, whichever we have set using this global configurations, right? So that user can access all these repositories. And the last one is local level configurations. These configurations or these settings are available for current repository only. So these are the various levels of configurations where we can do our configurations, and as per the level of configurations, user can access the repositories. So let's start with basic Git commands. So we are going to cover here init, add, commit and status. And to understand these commands, let's jump into the terminal window. So currently I am on user home directory. So let's jump into desktop directory. So cd desktop, and let me create one project folder. So mkdir git demo 1, right? So the folder is created. You can see git demo 1 here, and let me change the directory to git demo 1, cd git demo 1. So now we are in git demo directory, and as of now, if I do ls command, so there is nothing inside this folder, right? The very first thing when we are working on a project and we want to use the git, so we need to initialize our directory or project directory with git, right? And for that we have init command. So let me clear the screen. So what we need to do, git init, right? So you can see initialized empty git repository in users Parvinder desktop git demo 1, right? That is inside the git demo. So let me open this folder, and you can see there is a hidden folder .git. So this folder is hidden because we are not directly concerned with this folder, because that is something that Git will be using internally. So that is completely abstract from us. So we need not to understand what is the structure of this folder, what all these files are, and what all these folders are. So that's why this folder is hidden. We have initialized Git repository inside this so that we can use Git functionalities or Git features on this folder now, right? So next command we have is git status. So you can see status command is check the status of the repository, right? So at any time, so we can see like what is the current status of the repository. So status means, so we can see like what the files to be committed in the repository, or what are the newly added files in the repository. So everything we can check through this git status command. So for example, as of now, no commits yet, right? So let me add some file in git demo. So for that, we have text editor, and inside git demo, let me create one document, one dot, sorry, this is first file in git. So this is first file in git demo, right? And let me save this file. So 1.txt, save. And here now in this folder, we have 1.txt file, right? So let me hide the .git folder. Okay. So 1.txt, right? Now let's check git status, right? No commits yet, untracked file, right? So untracked file means, so we have added one file in this folder, but we haven't tell the git to add this file or track this file, right? So we have 1.txt. So whatever changes we are making in our repository, so we need to tell git we have added, we have updated, or we have deleted these files. So for that we have next git command, that is git add and file name 1.txt. Whatever the file you have added, updated, or deleted, you need to apply add command. And now if I check the git status, so you can see changes to be committed, new file is 1.txt, right? Previously it was untracked file because we didn't mention that to git like we have added this file or we have done some work on this file. But now we have added that file by using git add 1.txt, and now the status is new file 1.txt. So changes to be committed. Till this point, the changes are known by git, but these are not committed. And to commit these changes, so what we need to do, git commit, and along with commit we need to pass a message with flag -m and messages, for example initial commit, right? And you can see some message here, initial commit, one file changed, one insertion, right? And if now in this stage we check git status, so you can see after this git status we have nothing to commit, right? Working tree is clean means there is nothing which we can commit further. So everything is synced with git. So let me add one more file. This is second document, right? Let me do one thing more here. So I am changing something in 1.txt here. So we have added one new file 2.txt and some modifications. Uh, this is updated string, and let me save this and close this. Right now, if I check git status, you can see changes not staged for commit. So modified 1.txt and untracked file 2.txt. So there are two things we need to add using add command, right? So add doesn't mean we are adding something. Add means whether we are adding or we are modifying or we are deleting. So we need to add those changes inside git, right? So I will be explaining this little more. So for the time being, let's add git add 1.txt and git, and the next time I will be adding git add 2.txt. But if you have multiple files to be added, so what we can do, so git add dot, so everything is added. And if I check the status here, git status, so you can see the green text modified 1.txt, new file 2.txt, right? So changes to be committed. So let me commit the changes by using commit command, git commit message, and messages is modified 1.txt and added 2.txt, right? Enter. You can see two files changed. And finally, let me clear the screen and check the status, git status. So nothing to commit, working tree is clean. Okay. And here itself, let me do the final thing. For example, I am performing delete operation. For example, this file is deleted, right? And now if we see the status, we have deleted 2.txt, but git is not aware about this change as of now. That's why it is showing changes not staged for commit, right? So when we are adding something, so that thing is called staged, right? So let me do this first and then we will be trying to understand the workflow. So git add, either you can mention 2.txt or we can simply add dot here. And now check the status, git status. So these changes are staged. When we are looking this green text, right? So it means the things are staged. And finally, what we can do, git commit and file 2.txt is deleted. So any message we can pass here. And let me clear the screen and finally check the git status. Nothing to commit, working tree is clean, right? Init command we have already discussed. This is initialize git in the given project or folder, right? So we are using add, commit and status again and again. So add changes into staging phase, right? Commit, save the changes with a message, and status, check the status of repository. So let's try to understand add and commit through the workflow diagram. In this diagram, you can see the Git workflow. So we have the project directory and there is something called staging area, right? And finally, this is something like project snapshot or history. Whenever we are doing any modification in our project directory, so by using git add command, we are indicating Git that what kind of modifications, insertions or deletions we have done in our project directory, and those changes are just staged in this staging area. But this is not the final commit thing. From here, we can revert the changes as well, right? And once the things are staged here in this staging area, from here, we can do the final commit with the message, and for each commit, so there is a record in project snapshot history, right? And also this Git repository contains a complete snapshot of the current state of the project. So whenever you apply the Git commit, so the new record is added in this project snapshot history along with the complete snapshot of our project. So for example, in this diagram, I have added one new file here. So the same file is mentioned in staging area using git add command. And when git command is applied, so the new commit record is inserted in the project snapshot history. So this is the Git workflow. So how Git works internally. So till this point, we have used status command multiple times. So first thing, if we have added new files in our project directory, right, the status would be untracked. If we have done some modifications in our project directory, right, so we have done some modifications, then, or we have changed some file, then the status would be modified, right? And once the changes are added to the staging area by using git add command, then the status would be staged. And if there is no change in the project directory, then the status would be unmodified, right, or unchanged. So this is the way we get the status from git status command. So till this point, so we were executing these git commands through terminal, right? But going forward, we will be using our project IDE. So whatever the IDE we are using, whether it is Eclipse, NetBeans, IntelliJ, Android Studio, or any IDE, right? All these modern IDEs are integrated with terminal itself. So rather than opening a separate terminal window, so inside the IDE itself, we can open the terminal and we can execute our git commands, right? So for this demo, I am using Microsoft's Visual Code as my IDE, where I will be doing my project work as well as I will be executing my git commands. So here we have Visual Code. So let me enter into full screen. Okay, so in this window, you can see here we can open our project folder or we can create our new project here. And you can see here in the menus, we have this terminal and we can open the new terminal here. So I clicked here and this is the terminal. And we can use this terminal exactly the way we were using the outside separate terminal window. So for example, I want to see if Git is installed. So Git version. So we have Git installed in this system, right? And clear. So we can use clear command, cd desktop, cd git demo 1, git status, nothing to commit, right? So you can see we are using this terminal exactly the way we were using outside of this IDE, right? So let me open our folder, that is git demo 1. So this is git demo 1 and we have 1.txt, right? So let me add another file, for example 2.txt, right? And this is 2.txt file. Save it. So let me open the terminal window. So I pressed Control tilde symbol. So this is the shortcut to open this terminal window, or you can just open through terminal and new terminal, right? So as we have added new file, right? So let's check the git status now. So you can see untracked file, right? So to track this file using git, what we can do, git add 2.txt, right? And if I see the status now, git status, so new file is staged, right? And next to that, what we can do, git commit new file 2.txt edit, right? Git status, nothing to commit, working tree is clean, right? So this way we will be using everything inside IDE itself. So till this point, we have learned how to install Git on our local system and how to execute the Git commands, how we can add the files, delete the files, and modify the files in our project directory, right? And how to initialize the project directory with Git, and how to track the changes, right? So everything we have learned on our local machine. Another thing we have learned, that is GitHub. So how to create our account on GitHub, how to start a new project, or how to create the repository, right? How to add the files there, and all these modifications and commit messages. So everything we have seen online, right? Now we have learned these two things independently, right? The next thing what we are going to learn is how to associate our local project or local repository with online repository that is available on GitHub, right? So let's take example. So this is the Git cloud, right? And on this Git cloud, we have a project or repository, right? So for example, my repo. And here on our local machine, so this is our local machine, right? On our local machine, we have Git installed, right? So for example, this is Git installed, and we have initialized our Git repository here on our local machine. So for example, my local repo, right? And whatever the modifications we are doing here, for example, adding some files or deleting some files, modifying some files, right? So we just want every change should be synced with remote repo, right? For that, we need to associate this repo somehow with this remote repo, right? So that whatever changes we will be making on our local repository, so those changes should be synced with our remote repo. So for that, so we need to learn how we can associate our local repository with our remote repository. So this is next what we are going to do. Okay, so to associate local repository with the remote repository, so we have git remote command. So this is the command to associate local repository with remote repository, right? So first thing we need to do is let's create one remote repository. Okay, this is our repository homepage. Let me create new repository here. So new, let's call it second repo, right? Or we can add some description. Create repository. So here we have second repo, and in this section you can see we have HTTPS or SSH URLs, right? And to set up the remote connection or to set up our local repository with remote repository, we need this URL. And HTTPS is the most popular way to associate the local repositories with remote repositories. So let's copy this URL, and let me come back to my IDE on my local system. Okay. So here now we are in the IDE. So in the terminal, let me navigate to our desktop directory. So cd desktop. Here we can create our project folder. So let me create folder using mkdir and git demo 2, right? So let's navigate into this folder, cd git demo 2. So let me clear the screen. So we are in the git demo 2, right? So let's initialize git repository. So you can see initialized empty git repository in git demo 2 folder, right? So let's clear the screen one more time here, right? So the repository is initialized in git demo 2. Now here we need to set the remote. For example, git remote add origin, and the URL we have copied, right? So, and finally enter. To verify if remote is set or not, so we have command git remote -v, v for verify, right? So you can see the origin and remote is set for second repo, right? So what exactly this origin is, right? So let's try to understand. Here you can see we have used git remote command, right? So this is the git command, and we have this add. Because we are going to add remote, so we need to write add. So we have used some origin word here, and then we have applied the URL of our remote repository. So what exactly this origin is, so we are talking about this. So basically we have given this name, so which Git will be using internally to refer this remote repository. So we can keep any name in place of this origin, but origin is the quite common word that we use. So, or you can say this is kind of standard word. Basically this will be referring to our remote repository in many of the commands. So let's open the folder here in IDE. So basically git demo 2. There is nothing in this folder as of now. So let me create one file here. For example, 1.html, right? So this is the first file we have added here, and I'm just adding one heading here. This is 1.txt. So clear. For example, first let me check the status, git status. So untracked file 1.html, right? And we know we need to use add command. So git add 1.html. If we apply git status, so now this 1.html is staged, right? And finally we can execute commit command. So git commit message -m, we can say initial commit, right? So this way our file is now committed, or status is nothing to commit, right? So 1.html we have committed, right? So if I make some changes here, for example, this is the paragraph in my file, right? And now git status on branch master, nothing to commit, right? Working tree is clean, but we have made the changes, right? Why it is not showing? Because my file is not saved yet, right? So that's why. So let me save the file, and now git status, so modified 1.html, and let's quickly git add, and finally git commit -m, done some modifications in 1.html, right? And clear. So here, before moving ahead, so just wanna show you one thing. So there is a command git branch, so which tells in which branch we are working now. So like it is showing master. So currently we are working on master branch. So let's discuss quickly what exactly the branch is, right? A Git branch is a separate line of development that allows to work on new features or fixes without affecting the main project, right? So let's try to understand. So for example, this is our repository, right? So in this repository, so we have our project files and folders, right? So for example, we have multiple files and folders in this repository, right? So this is our project, or this can be online on our GitHub, or it can be on our local machine. So basically local repository. So here our main thing to understand is what is branch. So whenever we are working, right, so we always work on some branch. So branch is a copy of our project, right? So for example, this is the branch, right? So this is the copy of our project, and where we can make our changes. So usually in every repository, there is always a main branch or main repository, so whose name is always either master branch or main branch, right? So whenever we want to add some features, we want to make some modifications, so what is the approach always is, so from this main branch, so we always create some separate branch. So basically the separate branch is the copy of main branch, and we add some additional features on the top of this branch. For example, we have added some features in this branch, right? And then similarly, just like us, some other developer can be there, so who can make another separate branch for his separate features. For example, this is our main project, right? So main branch. In this branch, one developer, or in this piece of code or this complete copy of code, so some developer want to add some login feature, right? So what he did, so a separate branch is made, and independently he can work on this copy, and he can add his login feature, right? So login feature in this branch. And similarly, some other developer if working on that, so he can add his features, separate features on this branch. And for example, he wants to write change password feature, right? So at some point of time, so in this timeline, so once they are done, so this developer can merge his changes to the main branch. So for example, here our main branch, right? And he can merge his changes in this branch, basically in main branch. Similarly, the other developer also can merge changes into the main branch. So basically merge changes to the main branch. So this way, any developer can have independent copy of the original project, so which is called branch, and they can do any kind of modifications on that branch as per the feature they are working on. And finally, once the changes are done, they can merge their changes to the main branch. So this way, the main branch or master branch will be having the latest copy always, right, with all the changes. And again, so at this point, for example, so some developer want to add additional features, so he will be creating another branch for that, right? And in this branch, he can further do the enhancements, whatever the enhancements he wants to do. And once those enhancements are done, and again, he can merge his changes to the main branch. So this is the way we manage the branches, right? So we will be looking into that practically. So this was the definition for branch, what exactly the branch is, right? So here we have git branch command to see in which branch we are currently working. So this is the master branch. As of now, we haven't created the separate feature branches, right? Or the branches for further enhancements. We are directly working in the master branch only. So if we want to rename the branch, so for that we have command git branch -m. So for example, I want to rename this master to main, and now git branch, so branch is main, right? So currently we are in main branch, and we have done these changes. First one, we added one.html, and then we modified that file. And if we check the status, so everything is up to date in this branch and in this repository, right? So till this point, so we have local repository. So on Git cloud, so GitHub cloud, we have our remote repository, right? So let's call it remote repo. And on our local repository, so we have added some files. So in current case, so we have one.html, which is available on our local repository. And what we want to do, we want to push these changes to the remote repository. So here, to do that, so we need to use git push command. Okay, so let's see how we can use this command so that the copy of this file can be moved to the remote repo as well. So we have this git push command. So you can see send the changes from local repository into remote repository, right? And the syntax is git push origin branch name, right? Let's jump into the IDE. So you can see if I apply git status, so nothing to commit, right? So our local repository is up to date, everything is committed, right? So now we want to push these changes to our remote repository. So for that we have git push origin and which branch? Main. So we are sending this code to the main branch because we are currently working in the main branch itself. And first time you will be trying to push, so the extension GitHub wants to sign in using GitHub, right? So we need to log in, and it will be taking us to this screen. So user is let's code together user 1, continue, because in Chrome I have already logged in. So there is some access we need to give to our Visual Studio Code, right? So authorize GitHub for VS Code and authorize. So let's fill the password here. Confirm. Open Visual Studio Code. Yes. So you can see all the data is pushed from main branch local to main branch remote, right? So let's check online. So this is our second repo, and if I refresh this, you can see 1.html is there, and there are two commits. So initial commit and done some modifications in 1.html, right? So I am going back to the IDE. So let's create another file here. Let's call it 2.html, and let's write some code here. HTML body tag and paragraph. Hello, this is second file, right? We have written some HTML code here, and let's save this file. And here in console, let me clear this. So git status, we have untracked file 2.html, and git add dot and git commit -m, second file added, right? And finally, if we want to push these changes to our remote repository, so git push origin main, right? So you can see 2.html is there, second file is added, right? And in history, you can see 3 commits: initial commit, second commit, and third commit. So you can see every commit has some hash code associated with them, and we can see the time and user. So this is the user who pushed this commit 29 minutes ago, 27 minutes ago, and 1 minute ago, right? And we are in the main branch. So here you can see all the available branches. So as of now, we have only one single branch, that is main. So whenever some developer will be starting on some other feature, so the flow would be, he will be starting, he will be creating a separate branch, he will be working on that branch, and finally once his changes are done, he will be merging that branch into the main branch, right? Another thing I want to tell you here is, for example, we have done some modification in this file, update it, right? And now here, let me clear the screen. Git add, git commit, to file updated, right? Git push -u origin main. So I have added this flag -u. So this indicates upstream. So we have done these changes, right? Now, if you have mentioned your upstream, right? So next time you need not to mention origin main every time, because if you know every time you are pushing in the same branch, and every time you don't want to write the complete syntax including origin main, so we have defined our upstream, that is origin main, right? So now again, if I do some changes, and now git add, git commit, updated again, and git push, right? So without mentioning the origin main, So we have just written git push and the commit command is executed and the push command is executed successfully, and we can see the changes here. So to file is updated again, right? So all the changes we can see here. So next we have git clone command. So clone command is used to clone a repository from GitHub to your local machine. So for example, some project is initialized at GitHub, or there is some existing project on GitHub, right? And you want to bring that project on your local system. And for that we have git clone command. So the syntax for this is git clone, and then we need to mention the repository URL. Let's see this practically. So here in IDE, we have a fresh folder git demo 3. So in this folder, we want to clone some repository, right? So this is the first repository we have, right? And in under this code button, we have the URL for this repository. So copy this here, git clone and the URL, right? When I enter this, so you can see under this folder, first repo is cloned and the files 3.html, 1.txt file, all files are here, right? And now when we are cloning some project, we need not to set the remote for that. So let me verify the remote, git remote -v. So we are in the wrong folder. So cd first repo, right? And then get remote -v. So you can see the remote is correct, first repo.git, right? So when we clone the repository, we need not to set the remote. So clear, and I can make the changes same way we have discussed previously. So for example, I am deleting this line here and git add git commit updated 1.txt. So basically after making changes, I forgot to save this. So let's save this and then git add git commit updated 1.txt file, and finally git push origin main. And on our GitHub, let's refresh this. So now we have updated 1.txt file and the third line is deleted, right? So this is the git clone command. So how we can make a copy of existing project on our local system. Thanks for watching. In this video, we have covered the basics of Git and GitHub, including how to get started with installation, setting up your GitHub account, and some essential Git commands like init, add, commit, and pushing your code to a remote repository. But we have just prepared the surface. In the next video, part 2, we will dive deeper into more advanced Git commands and workflows. We will explore commands like pull, fetch, merge, and how to handle conflicts, work with forks, pull requests, and much more to take your Git skills to the next level. So be sure to subscribe and hit the notification bell so you don't miss out. See you in the next video. Thank you.